before we get rocking and rolling today. Okay, I'm gonna get going. Unless you're typing something, and then I'll stop. So the main thing is you need your TI 83, 84, whatever it is. You need this out because we're going to be utilizing it. And before we really get into 6.1 stuff, we're going to talk about stuff really from like pre-algebra, or I say pre-algebra, like if you came from the developmental algebra 2 class, we went over it, or it's really kind of an algebra 2 concept. And it was solving systems. So we're going to get to 6.1, but let's talk about this for a second. So solving systems of equations. Now I'm going to find, I think I've got my old intermediate algebra book here. Yeah, I'm going to find my book from last semester, and I'm going to dig up a good example of this. Now remember, solving systems is when we have more than one variable, but with that we have to have more than one equation. So it's really typically written as, you have to have the same amount of equations as unknown variables to solve it, right? Whew, we just got back from Thanksgiving break. I can tell my brain's not really kicked into gear yet, lecture-wise. So give me a minute to get warmed up. Let me find a good example here. Let's see. Oh yeah. So no, that's a horrible example. I remember really not liking the examples in this book. I'll find one. Give me just a second. Here we go. So if we had like 2x minus 4y equals 0 and x plus 2y equals 5. Okay, so this was two equations. We've got two unknown variables, the x and y. I'm going to label these equations equation 1 and equation 2. And in this section, we solved for x and y. And remember, on a graph, it's where they cross. And for us, so it's not going to matter. Hold on, this thing focused in a little better. It is not wanting to focus. Huh, that's right. But on a graph, that's where x and y would cross, or it's where these two equations would cross at a coordinate. And then we went over 3 different ways to solve the equation. I think the first one was by graphing it, right, to see where it crossed. The second one was either elimination or substitution. Those were the last two. I'm going to solve this with substitution because it kind of goes with what we're talking about today a little bit, in that it's going to be set up the same. This system of equation is really set up to solve with elimination, okay? And the way we did this, or the goal was to get the two, hold on. Yeah, to get opposite coefficients in front of the variables. So right now we've got a 2 and a 4 and a 1 and a 2, and we want opposite coefficients. Why is this thing not focusing? Ugh, man. And it must have taken a break as well. So to do that, and this is a review, right? To do that, we could multiply this entire equation by 2. Why is this not focusing? And when we distribute this, we'd wind up with, and I'm going to write it over here. I'm going to write the top equation, 2x minus 4y equals 0. And the bottom equation would be 2x plus 4y equals 10, right? We multiply the 2 all the way through. And notice the y's are opposite on these two equations, -4 and +4. That was the goal in solving, or the first goal, I should say, in solving using elimination. Now, when we do this, we add vertically. And you wind up with 4x. Now, look, this goes away. This is why we did it. 0y equals 10. And then if you do elimination properly, it'll cancel one of the variables. So we get 4x equals 10 by the 4. We get x equals 10 fourths. which winds up being 5/2, right? So this is our x variable. And now we've got to solve for our y variable, right? So the y variable, to solve for the y variable, you just took the x and then you plugged it into either one of the equations. I'm going to plug it into the second equation, the x plus 2y equals 5. And I'd have 5/2, because that's x now, right? Plus 2y equals 5. I'm going to subtract 5/2. I get 2y equals, now look, 5/2 is, well, you know what, you can use your calculator and do this in 2 seconds, right? Now let's clear this up. 5 minus 5/2, and then just hit the math fraction button. So all I did was just 5 minus 5. Look, nothing is in focus. Ugh. You wind up with 5/2 there. And then you multiply everything by 2. And you wind up with y equals, oh, I'm sorry, not multiply. Jesus, Robert. You divide by 2. So you multiply by 1/2, and you wind up with 5/4. So that would be our solution. X equals 5/2, and y equals 5/4. Okay? Hold on. Give me just a second. I'm going to do something a little weird. I'm going to try to get this focus thing issue because it's going to bother me. Give me just a second, guys. Or give it, Janie. Give me a second. I'm going to plug it. Hold on. I'm going to plug it and plug it back in. Okay. Oh, there we go. Okay, good. Yeah. Unplugging and plugging back in helped. That's awesome. So this was a basic example of solving a system by elimination. I'm going to try to find another one just because I feel like I kind of rambled through it. But this should be something that you've seen before. This shouldn't be a topic that's just foreign to you. Oh yeah, let's look at another one that has like nice answers. Yeah, this is okay. Let's look at another one. So let's say we had 5x plus 2y equals 1, and x minus 3y equals 7. Okay? 5x plus 2y equals 1, x minus 3y equals 7. We still have a system of equations, right? We have 2 equations. We've got 2 unknowns. We got an x and we got a y. And I'll tell you what we're about to go over in 6.1, we have to write it in this way too, where we've got the x's over the x's, the y's over the y's, and the numbers over the numbers with the equation over the equation, okay? So x plus y equals 1. I believe your book calls this standard form, something of that nature, but x and then the y and then the number. And now to solve this one, look, I notice on these x's, so this will be equation 1, this will be equation 2. On these x's, I could multiply by -5 here, and I could get the x to go away, right? Because it would put a -5 here. I'd have a +5 here. When I add vertically, they're going to go away. So I'm going to rewrite equation 1 to the right, 5x plus 2y equals 1. And then I'm going to multiply this -5 to everything, okay? And I get -5x plus 15y equals -35, okay? So yeah, negative, make sure I get the negative positive right. Positive 15y, and it's going to be a -35. Now look, when I add vertically here, the x's go away, right? Yeah, the x's go away, and so I'd have 17y equals -34 when I add these two vertically. I divide by 17, and I'd wind up with y equals -2. It's just an easier kind of answer here. Y equals -2. Now, I've got to solve for the x value, right? When I got the y value, I had to solve for the x value. I'm going to go back again to this bottom equation here. I'm going to say, well, x minus 3 times -2 equals 7, right? I just plugged it into the y value. So x plus 6 equals 7. Subtract the 6. And I wind up with x equals 1. So the solution was 1, -2. And what that meant was that if I drew these two equations, they crossed at the coordinate 1, -2. Just like in the previous example, if I drew these two equations, they would cross at 5 halves and 5 halves, 5 fourths. Okay, so I want to do this one just because it's nice whole number answers, or actually nice integer answers. Okay, so what does that mean about today? Why are you showing us this, Mr. Shirley, whenever you said it's clearly not the topic today? Well, we're going to solve these in a different manner using matrices. Okay, so let's talk just a minute now. I'll tell you 6.3 is really going to go over matrices more, and we'll talk more about the descriptors aspects of matrices. But 6.1 is on how to solve these equations with your using matrices. Let me get this book. I got the other book open. Let me get back onto the topic now. 6.1. Yeah, and your book goes over a lot of different things. And the very first thing it goes over is what's called reduced row echelon form. So, or I'm going to go over that first because that's what we're going to do today. Reduced row echelon form. Okay, but before we get there, we've got to talk about how to write those systems of equations as matrices. So I'm going to go back and use the example we did previously, that 5x plus 2y equals 1 and x minus 3y equals 7. Okay, so this is a system of equations. If I want to write this as a matrix, first I've got to use this little bracket notation there. So you write kind of a big bracket, and we're just going to write the coefficients. Now, you got to be careful because like if we didn't have an x, you'd have to put a 0 there. We'll get to an example like that, okay? But for now, we're going to just write the coefficients left to right. So, and again, it's got to go x, y, equal sign number. So 5, 2, 1, okay? 5, 2, 1. Very straightforward. And in the bottom row, so this will be our top row. We're going to close it off. The bottom row is going to be the other equation, 1, -3, 7, okay? So look, this is the system of equation. This is a system of equation written as a matrix, okay? Now I'll tell you, I'm giving away a little bit of 6.3. This is called a 2x3 matrix. That's its order because it has 2 rows and 3 columns. Okay, so this is a 2x3 matrix because it's 2x3. Now we're going to get to reduced row echelon form, what that means here in a minute. The goal of reduced row echelon form is that we only have, look, okay, I'm going to kind of write a vertical line here. Remember, that's where our equation is. That's where the equal sign is. Our goal is to only get 0 and 1s over here. And our calculator is going to do that for us. Now, if you want to see it done by hand, you're more than welcome to look through 6.1 and see how to do this by hand. Okay, not doing that. We're going to use that calculator to show how to solve these systems using matrices. And what we're going to do is the operation's called reduced row echelon form. So we've got this these two equations, two unknowns, written as a matrix. It looks like this. And now we're going to pop this thing in our calculator. Okay. So I'm going to go, I'm taking out the calculator. And if you notice the x to the -1 button right there, that button right there, if you hit second, that button, it will bring up your matrix like options. Hold on, let me do it. So second matrix. And I'm not sure if you've got like an older calculator or newer calculator, exactly what it says on the top, but I know if you go over to edit, and that's what we're going to do. We're going to go over to edit. We're going to edit that very first matrix. Okay, so go over to edit, and what we're going to do is we're going to make this matrix in the calculator. Okay, so I'm going to go over to edit. I'm going to edit matrix A. Now look, remember I told you the order for this matrix is 2 rows, 3 columns. So that's what we need to put in for the top. 2, enter, 3, enter. Now, if you've never done this before, it's just going to be all zeros there, right? Now, I've had this an old matrix in here, so it already had something in that edit window. So now I'm going to put this matrix into those spaces, okay? So I've got 5 first, 2, and then I got a 1. I'm just hitting enter each time. And then 1, enter, -3, enter, and 7, enter. Okay? So your matrix, when you do this, should look just like that. 5, 2, 1, 1, -3, and 7. So if you want to pause real fast, if it's not done, just hit pause and catch up. That's fine. But that's what it should look like. Janie, does yours look like that? Give me a thumbs up. And then once you've got it in there. Okay. Now I'm going to quit. So, if you hit the second button and right next to it, it quits, it'll make you go back to the main screen. So I'm going to hit second quit. And that just brings me back to the main screen. Now this is when we're going to do reduced row echelon form in the calculator. Okay. So I'm going to go back to my matrix options. So remember that was second, x to the -1. And the second option that, there was name at the very top here, there's names, math, edit. Well, we already have the matrix in there, matrix A. We need to go to math, and you're going to scroll down, and eventually you're going to see RREF. That's reduced row echelon form, RREF. So we're going to just keep scrolling down until we find RREF. Oh, there it is, 8. Okay, so number 8, when you scroll down on math, is RREF. And what that's going to do is it's going to create reduced row echelon form for this matrix. Okay, so we called that to the main screen. Now we're going to call the matrix we want to perform reduced row echelon form with. So for us, that's going to be matrix A, right? Remember, we named this matrix A at the beginning. So I'm going to do second matrix. And then I'm going to call that first one. See how it's under names? That's calling it. So I'm going to call matrix A. I'm going to close the parentheses, and boom, we did it. Okay, so this equation, or this system of equation in reduced row echelon form is 1, 0, 1, 0, 1, -2. Okay, it's hard to write right there. 1, 0, 1, and 0, 1, -2. Now, Janie, did you get that? Give me a thumbs up if you got that. Okay, do you know where you messed up? That's the real question. If you want to turn your screen on and show me something, that's fine. If you want to, did you have the original matrix in? If you go back to the matrix and you look at it, is it just lost with the buttons after the original matrix? Okay, yeah. Hit second, quit, boom. So that brings us to the main screen, right? And then we're going to bring up the reduced row echelon form. So you're going to go back into the matrix options and then go over to math. And the math is where you're going to find this RREF. So you just got to scroll all the way down so you get that. Okay, give me a thumbs up if you're there. Okay, now we've got to call the A in, or if we made that matrix A. So to do that, you hit the second matrix again, and your very first option is that A matrix that you edited earlier, right? So we're going to hit enter there, boop, and it should call it into reduced row echelon form, and then hit enter, and it'll do it. Should look something like that. Give me a thumbs up if you got there. Okay, good. Now, here, look. Now, at this point, I'm going to go back to my equation form. Now, we're not usually going to do this at the end, but just to show you how this relates. What this is telling me is that 1x plus 0y equals 1, right? 1x plus 0y equals 1. Here's our x's, here's our y's, here's our numbers. And 0x plus 1y equals -2. It has solved the equation for us. Look, this equation, it's 0y. X equals 1. This equation is just y equals -2. And remember, that's what we got previously. X equals 1, y equals -2 when we did this earlier doing the elimination method. But once we know the buttons here, it's going to be a lot quicker to do, okay? And really, we don't always do this with a two equation, two unknown. It's when we beef it up, when it becomes like 3 equations with 3 unknowns. And I'm going to do that now. Hold on a second. Let me find one that has like nice answers here, guys. So we don't want to, yeah, here we go. Whew, man. Okay, so let's do the same thing, but instead of 2 equations with 2 unknowns, let's kick it up to 3 equations with 3 unknowns. So if we had, let's say 3x plus, oh no, I already messed up. 3x I didn't mess up, plus y plus 2z equals 31. I'm stealing, this is example 592 in your book. I'm just stealing it. X plus y plus 2z equals 19, and x plus 3y plus 2z equals 25. Okay? So now look, now I've got 3 equations, 3 unknowns. Now again, if we're going to do this, we have to have all the x's in one column, all the y's in another, all the z's in another, and all the numbers in the last one, okay? So x, y, z number, x, y, z number. Now look, you're more than welcome to try this one. By elimination, it would be quite tricky. And you kind of have to do elimination within an elimination, because you have to eliminate the x's and then eliminate the y's, and then you wind up with the z's or something of that nature. I'm not going to go over that. You're more than welcome to get on YouTube and look up solving system of equations with 3 unknowns, and you're have at it. We're going to do this one though with the reduced row echelon form. It's going to be a lot quicker. So the first thing I've got to do is write this as a matrix, okay? Write this as a matrix. So this first row here is going to be 3, 1, 2, 31. Okay, 3, 1, 2, 31. Close that off. And then the next row is going to be 1, 1, 2, 19, right? And the bottom row is going to be 1, 3, 2, 25. So I'm going to go in now, and I'm going to use my calculator from here on out. So I'm going to go back, and I've got to put this in my calculator. Look, I'll put this in as like matrix B, okay? So we'll call this one matrix B. So, so again, I'm going to go second matrix, and now I got to edit, right? Edit matrix B, because I want this now as matrix B. Now the order for this one, look, I've got 3 rows and 4 columns. So the order is going to be 3 by 4. So at the very top, that's the very first thing. I didn't go over this one before, did I? But at the very top, when it asks you, it says like 1 by 1 for me because there's nothing in there. I want to make that 3 by 4. And I just hit enter after each number I want. And notice now it brings up a 3 by 4, all zeros, but a 3 by 4 matrix. Okay, so I'm going to go 3, enter, 1, enter, 2, enter, 31, enter, 1, enter, 1, enter, 2, enter, 19, 1, enter, 3, enter, 2, enter, 25. I think that's everything. I'm going to check it, kind of match it here. 3, 1, 2, 31, 1, 1, 2, 19, 1, 3, 2, 25. Yep. Okay, good. So now once I have it in there, I go back to the very beginning. So I'm going to do second quit. Okay. So once I have B in, I'm going to do second quit. I'm at the very beginning home screen. And now I'm going to do, my goal now is to just do RREF. But remember, I'm going to call B now because we called it B. Now, if you called it A, that's fine. You can call it whatever you want to do, as long as you know where this matrix is. So to bring RREF, I know I've got to go under that matrix math. So second matrix again. I'm going to go under math. I think it's like, it wasn't 8. Was it B? I was saying it was 8, didn't I? It's B, not 8. So bring in RREF. And now I've got to call the B matrix. So second matrix. And now I'm going to call B. So that's the original one. Call B. And then hit enter. Boom. So this gives me 1 0 0 6 0 1 0 3 0 0 1 5. Now remember, and I didn't mention this on that last one, I told you the goal was to get, remember, if we think of where the equation line is, where the equation is, everything to the left of that is zeros and ones, because what that does is it gives me the solution, right? If I wanted to write this as equations, it would be 1x plus 0y plus 0z equals 6, and so on. Now, I'm not going to do that. I'm just going to pull out the solutions from this matrix. Look, this is my x value. That's my solution. So I know x equals 6. Remember, this is my y column. The other two are 0. So y equals 3. And this is my z column, right? So z equals 5. Boom. Shakalaka. Okay. Pretty neat stuff. I know. You don't have to tell me. I know this. It is pretty cool. Okay. I know what you're thinking. You're thinking, Mr. Sherlock, what if we had 4 equations with 4 unknowns? And guess what? You can do that with this reduced row echelon form. Now, Jamie, before we go on this next one, it's not a big deal. We're just adding another variable. Do you have any questions? You can give me a thumbs up if you don't. Do you have any questions? Okay. So I'm stealing this one from your book. This is on page 600. And we're going to do number 30. Let's do 36. 36. It's kind of situated a little bit. 36 states W plus X. You know, we haven't done one where there's not. Let's do 38. Let's do 38 because I said I would do one where we had missing variables. So 38 says 2W plus Y minus 3Z equals 8. W minus X plus 4Z equals negative 10. 3W plus 5X minus Y minus Z equals 20. And W plus X minus Y minus Z equals 6. I think I wrote that down correctly. 2y, y negative 3, W 4, 3W 5 minus Y minus Z, and W X Y Z. Yeah. And then 8, negative 10, 20, and 6. Yeah. Okay. So we've written this down correctly. But notice on some of these, look, there's 4 variables now, but there's 4 equations. So we can solve this one, right? 4 variables, like 4 variables across here, 4 equations, we should be fine. But notice like some of these equations, like this first equation, it doesn't have an X, right? So wherever we decide our X column to be, we need to put a 0 there. So it looks like your book's wanting you to do, if like we look at this third equation, it goes W, X, Y, Z, okay? So I'm going to write my matrix like that. So I'm going to go W column, you know, just to keep it situated, W, X, Y, Z, and then there's going to be a number, right? W, X, Y, Z, and then a number. So this first equation, it's going to be 2. There's no X, so I've got to put a 0 there, okay? 1y, negative 3z's, and 8's the number. So w, so that's 2w. No x's, so I got to put 0. And then y is 1, negative 3, and 8. And then so the next line, we've got 1w, negative 1x, but we don't have any y's, so we have to put a 0 there. 4z's and negative 10. The next equation has all of them, right? So 3w's, 5x's, negative 1y, negative 1z, and then 20. And then 1, 1, negative 1, negative 1, and 6. Okay. Great. Look, all we have to do is, we'll call this one C. Why not? That's better. So I'm going to take C and I'm going to put it in reduced row echelon form. And we're going to solve for X, Y, Z, and W, right? X, Y, Z, and W. Okay. So let's go back here. Turn mine on, went off apparently. And then we're going to go to second matrix, edit. Now for this one, it's going to be a 4 by 1, 2, 3, 4, 5. So this is a 4 by 5 matrix, okay? So 4 by 5, there's a lot going on here. 2, 0, 1, negative 3, 8. That's my first equation. 1, negative 1, 0, 4, negative 10. 3, 5, negative 1, negative 1, 20, 1, 1, negative 1, negative 1, and 6. That looks right. 2, 8, 10, 3, 5, negative 1, negative 1, 20, 1, 1, negative 1, negative 1, 6. Yeah, I mean, it's extremely important that we put these in correctly, right? Check it twice or 3 times if you have to. But now I'm going to do the reduced row echelon form with matrix C. So I'm going to quit out of here again, and then I'm going to go second matrix. Got to do the math. Oh, second matrix. Go over to math. Go over to B, not 8. Boom. And then I'm going to do second matrix. I'm going to call C, right? Bam. I mean, 1, 0, 0, 0, 1, 0, 1, 0, 0, 3, 0, 0, 1, 0, 0, and 0, 0, 0, 1, negative 2. Okay, now I got to be careful. Remember, this first column was W, okay? So that means W equals 1. The next column was X, so X equals 3. And then Y equals 0. And then lastly, Z equals negative 2. Okay, pretty cool stuff. Pretty cool stuff. Okay, so for homework in this section, I just want you to be able to do this with a calculator. It's going to pop up on the final. So I want you to be able to do this on the calculator, and then, in the next class, come ask me if you're having issues with it. If it's not clicking, if it's not working, let me know, or go back and watch the video, just watch kind of the step-by-step. The most common mistakes are students not putting it in correctly in the calculator. So you'll wind up with real funky answers. Like say we should have gotten 1, 3, 0, 0, 0, negative 2. You'll wind up with like 1/3, negative 2,000. I mean, you get some goofy answers if you mess up with the matrix at the very beginning. Okay, if you mess up inputting the matrix from the get-go. Okay, so for homework in this section, now we're going to go on to 1.3. But for homework in this section, I want you to do 1 through 11. Okay, and that's going to be odd. And then, okay, I want you to do something a little different for the last part, 21 through 37. I just want you to solve like we've been doing, okay? Solve your book has something like solve each system of equations using matrices. Use Gaussian elimination with back substitution or Gauss-Jordan elimination. Don't worry about that. I just want you to solve using that RREF, okay, using the reduced row echelon. I want you to solve that last section. Now, the first section is just about writing these in matrices and vice versa, putting them back in equations. That's fine. But 21 through 37, I want you to solve doing reduced row echelon form. It's on page 599. Okay, page 599, section 6.3. Okay, awesome. So now let's go on to 6.1. This is not 6.3. This is 6.1. Okay, we're going to go on to 6.3 now. So 6.3, in my opinion, 6.3 should be the way Dr. Blitzer has this book written. 6.3 should really kind of come before 6.1, but I understand his thought process on why it doesn't, but it just makes more sense. 6.3 is on, basic operations of matrices. Called basic matrix operations. I think that's kind of what he talks about. Now, the first thing your book goes over is the order of matrix. We've already done that, and I'll kind of mix it in as we go. After the order, though, we're going to talk about the addition and subtraction. So let's actually talk about the order with addition and subtraction. If you're going to add or subtract matrices, the matrices have to have the same order. So if we look, and it's really basic, okay? So if we looked at, let's say, a matrix, two matrices with like 3x2 orders. So if we have like 1, 2, 0, -3, 4, and 5, okay? You can tell this matrix has a 3x2 order, right? There's 3 rows, 2 columns, okay? Now, each part of the matrix, each component has a position. So the position is actually how you think of this order in a way. So like, let's call this matrix A. We'll talk about this just for a minute. We'll call this matrix A. And if I wanted to talk about a very specific position, I would use this row by column way of doing this. So if I wanted position, let's say 4 right here, this would be the third row, first column. So A, 3, 1, okay? This would be 4. So it's going to be, if you see A3, 1, that means it's the third row, first column. So, and that's 4. So that's its position. A3, 1 is the position right here. Where if I did, let's say A1, 2, it's not 12, okay? It's 1, 2. And what that means is it's the first row, second column. So first row, second column is the number 2, okay? So that's the position aspect of these matrices. Now look, when you add these matrices together, now if you're going to add, you have to have the same order. Let's just make one up. Let's say -4, 5, 2, 7, -3, and -5. Call it matrix B, okay? If we want to add these together, what we're going to do is we're going to add the order or the positions. So like A11, which is right here, we're going to add that to B11. And it's going to wind up with our solution matrix position. So 1 plus -4, -3, okay? 2 plus 5, that's a +7. 0 plus 2, that's a +2. -3 plus 7, that's a +4. 4 plus -3, that's a 1. And then 5 plus a -5, that's a 0. Okay. So, and again, it creates another matrix with the same exact order because you're adding across the matrices. You're adding across the matrices and you're just adding the positions across the matrix. Okay. Questions, comments, concerns? And guess what? Subtraction would be the same way. Not a big deal. Okay. I'm not going to stick too long on addition or subtractions of matrices. I'm not too worried about it. Equality of matrix is the same. I want to say it's pretty easy as well. We'll talk about that for a minute. If we had two matrices that are equal to each other, that means their orders again have to be the same. I'm going to steal one from your book. It says, let's see here. Let's say if A equals x, y plus 1, z 6, and B equals 1, 5, 3, 6. So we've got the A matrix, x, y plus 1, z and 6, and then B is 1, 5, 3, 6. So notice each of these are 2 by 2 matrices, okay? Now this position has a little binomial in it. There's nothing wrong with that. That's that A1, 2 position. It's y plus 1, but they're both 2 by 2 matrices. So if A equals B, we can say that the positions are equal to each other. So if A equals B, then A11, which is x, has to equal B11, which is just 1. Okay, x equals 1. A12, which is y plus 1, has to equal B12, which is 5. Now I've got to subtract 1, and I wind up with 4. Y equals 4. Okay? Z would have to be 3. And then we know 6 equals 6. We're not worried about that one. Okay, so we solved for these unknowns because we know that these two matrices are equal to each other. So if two matrices are equal to each other, you can set each position equal to itself, okay? Equal to the other matrices position, okay? Questions? Jamie, do you have any questions? I know I'm zooming through this, but this is the super duper easy stuff when it comes to matrices. And when you see it in the homework, it's pretty easy. I mean, if you have a question, please ask me. Or if you want to email me, guys, when you're watching this later on, just ask me. But this isn't the harder stuff. Okay. Yeah. So now let's go on to multiplication. So there's two types of multiplication. There's scalar and multiplication of matrices. So let's start with scalar. Scalar multiplication. Scalar multiplication means we're just multiplying a number through the matrix. So I'm going to go back and use that same A matrix as earlier. It was 1, 2, 0, -3, 4, and 5. Okay. Scalar matrix with a scalar multiplication, all you're going to do is multiply a number completely through. So it would look like this. Like, actually, you know what? Let's call these capital letters. Typically, they're written as capital letters. Okay. So if I want to do scalar multiplication, I would just do something like 2a. Okay. And what that means is I'm going to multiply 2 through this matrix. Okay. So you're going to multiply 2 to every position in the matrix. So we wind up with 2 times 1, that's 2. 2 times 2, that's 4. 2 times 0 is 0. 2 times -3, -6. 2 times 4 is 8. And 2 times 5, which is 10. So that's 2a. Super duper easy. Okay, that's scalar multiplication. You just multiply a number throughout the matrix. Okay. Matrix multiplication is a little different. Matrix multiplication takes a little more time, and I'll kind of give you my goofy way of doing this, but it just takes a little more time. So let's look at matrix multiplication. Let's say we had two matrices with second order, or they're both 2 by 2, I should say. I'm going to maybe steal one from the book. Where am I in the book? I'm a little ahead. So 2, 3, 4, 7. I'm going to multiply that by 0, 1, 5, and 6. Okay, we'll call this one A and this one B. Okay, this one's going to take a little more thinking to do than just the scalar multiplication. I'm going to try to use another color to try to bring in some color. So the way you do this actually is you take the first row here, and I think of it like dunking it into the first column of the second matrix. So the first row of the first matrix, you're going to dunk it into the first column of the second matrix. So it's like, think of it like this. I take this off, kind of detach it off, and I drop it onto this first row. Okay. Now, I'm going to write this kind of bigger here. Now, when I do that, now think about doing this. If I take this off and then I drop it in, think of this. The 2 would be on top of the 0. Boom. Drop it in, the 2 would be on top of the 0, right? Take this off, I drop it in, the 2 would be on top of the 0. The 3 would be on top of the 5. If they're on top of each other, you're going to multiply. So 2 is on top of the 0, so it's going to be 2 times 0, plus the 3 is on top of the 5. 3 times 5. That's going to be the first position of our solution matrix, okay? So, or our product matrix, I guess you could say. That's going to be our first position. Now, since I have another column here, I've got to go one more column over. And I'm going to do the same exact thing, okay? So I'm going to take this row, and then I'm going to drop it into that column. And when I do that, the 2 is on top of the 1. So 2 times 1, right? And then the 3 is on top of the 6. Now look, I don't have another column to dunk this in. So I'm going to stop there. And I'll tell you, in the past, I've like jokingly thought of this as like cheese sticks. We're like, here's my cheese stick. Here's my sauce. I got marinara, dunking it in. I've got honey mustard. If you never had cheese sticks with honey mustard, you're really missing out. You should try it. Boom, dunking it in. If we had another column, you can think of it like ranch or whatever, ketchup, but whatever floats your boat, okay? But the idea is to take the column and dump it into the row, okay? And now look, I've got no more columns to dunk it in, so that's why I had to stop. So now I'm going to go down, though, to this bottom equation. Do Christmas colors, because we're almost to Christmas break. Okay? And I'm going to do the same thing. I'm going to take this 4 and 7, and I'm going to recreate my Duncan, okay? So 4 and 7, drop it in. And notice now, if you do that, 4 and 7, the 4 would be on top of the 0. And the 7 would be on top of the 5. So think about that. 4 would be on top of the 0, 7 would be on the 5. And then the last one, boom, 4 would be on top of the 1. And 7 would be on top of the 6. And now we've just got to do kind of the basic math going on here. Okay, so let's see. This first position, 2 times 0 is 0, plus 3 times 5 is 15. So 15. The second one, this would be 2 plus 18, right? So 20. 4 times 0 is 0, so 7 times 5, 35. And then 4 times 1 is 4. And then 7 times 6 is what? 42. So that's going to be 42 plus 4, 46. Okay, and there we have our matrix after we multiply. We multiply this matrix together. Pretty cool stuff. Okay. Questions? Janie, do you have any questions other than, I think I need to see that again? I'm going to do another example of it. I got to make some rules for it. Okay, the rule for this, and it has to do with, look, when we dunk these in, like when I dunk this row into this column, the number of column, or it's the number of columns of the first matrix have to equal the number of rows of the second matrix, okay? And let me show you what I'm talking about. For this one, it's easy because these are all 2 by 2 matrices. But let's look at another example. I'll have to steal one. Yeah. Let's say we had 1, 2, 3, 4, 0 to -1 and 6. And we had 4, 2, 1, and 3. Okay, I had that sideways. So this is actually on page 620. It's the example 7 at the top. But I'm doing them out of order to show you what I really want to get to. Now notice if I wanted to write the order of this matrix, it would be a 2 by 4. And we know the order of this matrix is just 2 by 2. And if I want to multiply these together, and I think of them as, dunking the cheese sticks in. So if I take this entire row here, notice there's 4 of them, right? And I plop it in, look, notice that I've got 4 numbers, but I've only got 2 spots to dunk it into, right? 4 numbers, but only 2 spots to dunk it in. It's not going to work. These have to overlap when you do the dunking, okay? The number of numbers here, the amount of numbers here has to be equal to the amount of numbers here because they have to overlap. And so what that means is, look, we just can't multiply these 2 matrices together, okay? Can't multiply. Now, the quick way to check this, though, is the number of columns, which is your second number here in this order, has to equal the number of rows, which is your first number here. These 2 numbers have to be the same, okay? These 2 numbers have to be the same. And if they're not the same, we just can't do the multiplication. So now I'm going to change the order here. I'm going to write that second matrix first. So I'm going to say, try to use a lot of paper. 4, 2, 1, 3. 1, 2, 3, 4, 0 to -1 and 6. Now look, this is 2 by 2. This is a 2 by 4. Okay. Notice the order for the number of rows in this equation. Wait, no, it would be columns. The number of columns in this equation, good Lord. The number of columns in this matrix equals the number of rows in this matrix. So these 2 are the same. So that means we'll be able to multiply them together. Okay. This is going to take a little time, but we're going to do it. We got a little time. This might be my last example of the day. Yeah. Okay. So I'm going to take this column, or this row, good God, this row, and I'm going to dunk it into each one of these, right? All 4 of them. Okay, so I'm going to write this out. This is going to take a little. So I take 4 by 2 and I dunk it into this first column. The 4 is going to be on top of the 1. So 4 times 1 plus 2 times 0, right? Then I'm going to dunk it in the second one, which they're both 2. That's kind of nice. But the 4 will be on top of the 2 plus the 2 on top of the 2. The next column, 4 is going to be on top of the 3 plus 2 is going to be on top of the -1. Okay. The last one, 4 is on top of the 4 plus 2 is on top of the 6. And we don't have any more to go into, right? So I'm going to stop it there. So now we've got to go to the second row and do the same exact thing, right? We're going to do the same exact thing, but we're going to do it with this bottom row, those 2 numbers on the bottom row. So 1 times 1, because 1 is going to be on top of the 1, 3 is going to be on top of the 0. 1 times 2 plus 3 times 2. It's okay if you're not going as fast. Just go at your pace. Boom. 1 times 3 plus 3 times -1. And then 1 times 4 plus 3 times 6. Okay. And now we've got, look, notice we have we're going to have a 2 by 4 matrix here. Let's see that. So this first little binomial, let's say binomial, first little expression, if we solve it out, 4 times 1 plus 2 times 0, 2 times 0 goes away. We're left with 4. The second one, now this is a times. 4 times 2 is 8, plus 2 times 2 is 4. So 8 plus 4, 12. 4 times 3 is 12, plus negative 2, so that's 10. 16 plus 12. 16 plus 12, is that 28? 28. And then this bottom row, so it's going to stop that one. It's just 1. 2 plus 6, so that's 8. 3 plus a negative 3, oh, that's 0, right? And then 4 plus 18, that's 22. We multiplied these matrices out. Pretty neat. Okay. Pretty neat. I know. You don't have to tell me. Okay. Okay. So the homework for this section. So this is section 6.3, page 624. 1 through 1 through 35 odd. Oh, I lied. Hold on. 1 through 43 odd. 1 through 43 odd. So try those, and look, we're gonna, if you've got questions on those, please email me.